When determining box fill requirements in an electrical box containing both switches and a receptacle, the calculation method focuses on the conductor size connected to the receptacle. For the purpose of box fill calculation, the larger conductor size connected to the receptacle is what needs to be considered. If you have a 3-gang box containing 2 switches wired with number 14 American wire gauge conductors and 1 receptacle wired with number 12 American wire gauge conductors, you would only use the number 12 American wire gauge conductors for calculating the box fill allowance related to the receptacle. The number 14 American wire gauge conductors associated with the switches do not contribute to the box fill calculation in this specific scenario, since the receptacle uses number 12 American wire gauge conductors. The National Electrical Code, or NEC, provides guidelines for determining the maximum number of conductors, devices, and wiring components permitted in an electrical box. These guidelines are intended to prevent overheating, ensure safe connections, and allow sufficient space for proper heat dissipation. Box fill calculations are a critical aspect of electrical installations to comply with these safety standards. To perform a box fill calculation, several factors must be considered. Firstly, the volume of the box itself, which is typically measured in cubic inches. This information is usually marked on the box. Secondly, the number and size of conductors entering the box. Each conductor has a specific volume allowance based on its gauge size, as specified in the NEC. Thirdly, the number of device yokes, such as switches, receptacles, or dimmers. Each yoke counts as a certain number of conductors based on the wire size connected to it. Fourthly, the number of equipment grounding conductors. These conductors also contribute to the box fill calculation, although typically all equipment grounding conductors are counted as a single conductor based on the largest grounding conductor entering the box. Fifthly, the number of cable clamps, if internal to the box. Each clamp counts as 1 conductor. Sixthly, any devices or equipment installed in the box, such as splices or fixture studs. The NEC provides specific tables and formulas for determining the conductor fill allowance for different wire sizes. For example, NEC Table 314.16 provides the conductor fill allowance based on wire size. Number 14 American wire gauge conductors have a smaller volume allowance than number 12 American wire gauge conductors, and number 10 American wire gauge conductors have a larger allowance than number 12 American wire gauge conductors, and so on. When calculating the box fill for a box containing switches and receptacles, you must consider the volume occupied by each component. Each conductor entering the box contributes to the total volume. The number of conductors is determined by counting all the current carrying conductors, neutral conductors in certain situations, and equipment grounding conductors. Device yokes, such as switches and receptacles, also contribute to the box fill calculation. According to the NEC, each device yoke counts as 2 conductors based on the largest conductor connected to the device. Therefore, if you have a receptacle wired with number 12 American wire gauge conductors, the receptacle yoke counts as 2 number 12 American wire gauge conductors. In the scenario described, where you have 2 switches wired with number 14 American wire gauge conductors and 1 receptacle wired with number 12 American wire gauge conductors, the box fill calculation would proceed as follows. Firstly, calculate the volume occupied by the number 12 American wire gauge conductors connected to the receptacle. Since the receptacle is wired with number 12 American wire gauge conductors, the receptacle yoke counts as 2 number 12 American wire gauge conductors. Secondly, calculate the volume occupied by the number 14 American wire gauge conductors connected to the switches. However, in this specific case, the number 14 American wire gauge conductors connected to the switches are not considered for box fill calculation because the receptacle uses number 12 American wire gauge conductors, which are larger. The general principle is that the device yoke is counted based on the largest conductor connected to it. Therefore, even though the switches are wired with number 14 American wire gauge conductors, they do not affect the box fill calculation when a receptacle wired with number 12 American wire gauge conductors is also present in the box. It is important to note that this calculation method applies specifically to device yokes. Other conductors in the box, such as equipment grounding conductors and neutral conductors, must still be included in the overall box fill calculation, regardless of the presence of switches or receptacles. To summarize, when calculating box fill in a box containing switches and a receptacle wired with different conductor sizes, you only use the conductor size connected to the receptacle for calculating the box fill allowance related to the receptacle yoke. The conductors connected to the switches are not considered in this specific scenario. This ensures that the box fill calculation is accurate and complies with the NEC requirements for safe electrical installations. For example, consider a 4-inch square metal box with a depth of 2.125 inches. According to NEC Table 314.16. This box has a volume allowance of 30.3 cubic inches. Suppose this box contains 2 switches wired with number 14 American wire gauge conductors, 1 receptacle wired with number 12 American wire gauge conductors, 3 number 12 American wire gauge equipment grounding conductors, and 4 number 14 American wire gauge conductors used for the switch legs. To calculate the box fill, we would proceed as follows. Firstly, determine the volume occupied by the number 12 American wire gauge conductors. The receptacle yoke counts as 2 number 12 American wire gauge conductors. The 3 number 12 American wire gauge equipment grounding conductors are combined and counted as 1 number 12 American wire gauge conductor. According to NEC Table 314.16. The volume allowance for a number 12 American wire gauge conductor is 2.25 cubic inches. Therefore, the total volume occupied by the number 12 American wire gauge conductors is 2.25 cubic inches multiplied by 3, which equals 6.75 cubic inches. Secondly, determine the volume occupied by the number 14 American wire gauge conductors. The 4 number 14 American wire gauge conductors used for the switch legs must be included in the calculation. According to NEC Table 314.16. The volume allowance for a number 14 American wire gauge conductor is 2 cubic inches. Therefore, the total volume occupied by the number 14 American wire gauge conductors is 2 cubic inches multiplied by 4, which equals 8 cubic inches. Thirdly, add the volumes to find the total box fill. The total box fill is 6.75 cubic inches plus 8 cubic inches, which equals 14.75 cubic inches. Fourthly, compare the total box fill to the box volume allowance. The box volume allowance is 30.3 cubic inches, and the total box fill is 14.75 cubic inches. Since the total box fill is less than the box volume allowance, the installation complies with the NEC requirements. In another scenario, consider a 3-gallon box made of plastic with each can having a volume of 20 cubic inches, resulting in a total volume of 60 cubic inches. In this box, you have 2 switches, each wired with number 14 American wire gauge conductors, 1 duplex receptacle wired with number 12 American wire gauge conductors, 4 number 14 American wire gauge conductors for the switch legs, and 2 number 14 American wire gauge equipment grounding conductors. To calculate the box fill, firstly determine the volume occupied by the number 12 American wire gauge conductors. The duplex receptacle yoke counts as 2 number 12 American wire gauge conductors. According to NEC Table 314.16. The volume allowance for a number 12 American wire gauge conductor is 2.25 cubic inches. Therefore, the volume occupied by the number 12 American wire gauge conductors from the receptacle is 2 multiplied by 2.25 cubic inches, which equals 4.5 cubic inches. Secondly, determine the volume occupied by the number 14 American wire gauge conductors. You have 4 number 14 American wire gauge conductors for the switch legs and 2 number 14 American wire gauge equipment grounding conductors. The 2 equipment grounding conductors are combined and counted as 1 number 14 American wire gauge conductor. Therefore, you have a total of 5 number 14 American wire gauge conductors. According to NEC Table 314.16. The volume allowance for a number 14 American wire gauge conductor is 2 cubic inches. Therefore, The volume occupied by the number 14 American wire gauge conductors is 5 multiplied by 2 cubic inches, which equals 10 cubic inches. Thirdly, add the volumes to find the total box fill. The total box fill is 4.5 cubic inches plus 10 cubic inches, which equals 14.5 cubic inches. Fourthly, compare the total box fill to the box volume allowance. The box volume allowance is 60 cubic inches, and the total box fill is 14.5 cubic inches. Since the total box fill is significantly less than the box volume allowance, the installation complies with the NEC requirement. In summary, understanding and applying the correct box fill calculation methods is essential for ensuring safe and compliant electrical installations. Always refer to the NEC guidelines and tables for accurate conductor fill allowances and device yoke calculations. By following these practices, you can prevent overheating, ensure secure connections, and maintain the integrity of electrical systems.